Features about radiation heat transfer. As we know, heat is flowing energy between high temperature to low temperature, and heat flows from high temperature to low temperature in three modes. The first mode is conduction, the second mode is convection, and the third most prevailing mode of heat transfer, that is radiation. We receive sunlight from the sun by a mode of radiation. Out of these three modes, the conduction mode and convection mode, they need medium for transferring heat. But radiation is a mode of heat transfer which do not require medium for transferring heat. It means radiation can transfer itself through vacuum also. So what is basically radiation? Radiation is, suppose we consider a surface. Radiation is coming out of this surface, means energy is coming out of this surface in the form of electromagnetic waves. So radiation energy transfer is nothing but emission of electromagnetic waves. And what are electromagnetic waves, and why this surface is emitting electromagnetic waves? Electromagnetic waves, as all electronics engineers say, electromagnetic waves are nothing but group of photons. They call it swarm of photons. And why the surface emits electromagnetic waves? Because all inorganic materials consist of large number of molecules. They are vibrating at various spaces. So because of that, the electromagnetic waves in the form of photons come out, and these electromagnetic waves have a property of traveling in a straight line. It means, suppose we consider this wall or this wall as our surface, and it is emitting electromagnetic waves, then the waves will travel only in straight line. It can be an inclined straight line, not necessarily a horizontal straight line. So what is radiation is nothing but electromagnetic waves, and the waves has got property of traveling in a straight line. Now when this surface will emit electromagnetic wave, this surface will emit electromagnetic wave only when its temperature is greater than 0 degree Kelvin. 0 degree Kelvin, also equal to minus 273 degrees Celsius, is called absolute zero temperature. And whenever we have a surface or body whose temperature is greater than absolute zero Kelvin, the surface or body will emit radiation in the form of electromagnetic waves. At absolute 0 degree Celsius, what happens is, that is at minus 273 degrees Celsius, the velocity of the vibrating molecules becomes zero. So the temperature at which the velocity of molecules inside a body becomes zero, that temperature is termed as absolute zero or 0 degree Kelvin. So the electromagnetic waves or radiation are emitted by any body or surface whose temperature is greater than 0 degree Kelvin. So all bodies, all surfaces present in nature, they have temperature more than 0 degree Kelvin, because this 0 degree Kelvin temperature at which all molecular motion ceases is hypothetical. It cannot be achieved. So any body it has got temperature greater than 0 degree Kelvin, so all bodies will emit electromagnetic waves. Now these electromagnetic waves has got certain frequency and certain wavelength. So when we study radiation, we study electromagnetic waves. When we study electromagnetic waves, we study frequency and wavelength. And as we know, the basics of electromagnetic waves, if wavelength is short, the frequency is more. Best example is the sun rays. Sun rays come from a very long distance to Earth. The wavelength is very short and frequency is very high. So radiation has dual nature. One is it follows wave theory, and other is it follows particle theory. What is meant by wave theory we have seen, because radiation is in the form of electromagnetic waves, so all the rules and regulations for wave theory, they are applicable to radiation. Particle theory means we can consider the electromagnetic wave as a group of particles and we can consider each particle of that group and study how much heat that particle is carrying. So radiation is dual in nature, it follows both theories. Now all electromagnetic waves coming out of any body or surface, they are not called thermal radiation. Only the wavelength between 1.1 microns to 100 microns, the electromagnetic wave which has got wavelength between this range, that electromagnetic wave is called thermal radiation. Suppose we have a surface, this surface may emit electromagnetic waves of say wavelength lambda 1, lambda 2, lambda 3, lambda 4. So at number of wavelengths electromagnetic waves are coming out. But that wave which has got wavelength between this range is called thermal radiation. Why? Because thermal radiation is a three-step process. Step number 1 is emission of electromagnetic wave. Step number 2 is transport of electromagnetic wave in some medium or without medium. So the first two steps are emission of electromagnetic wave, second is transport of electromagnetic wave, and third, the most important step is conversion of electromagnetic wave into internal energy at the target surface. Suppose this is a surface, electromagnetic wave has come out from this surface, this is step number 1, it is being traveling through space or through some medium, this is step number 2, and this is the receiving surface. Once this wave reaches this surface, this electromagnetic wave is converted into internal energy. And what is internal energy? Internal energy is a function of temperature. So the surface, the target surface gets internal energy, means the internal energy of the target surface increases and means temperature increases. So these three steps are followed by the electromagnetic waves whose wavelength is between 0.1 to 100. So this range is called thermal radiation. This range is called thermal radiation. One most important feature of radiation is higher the temperature of the body or surface, higher is the radiation. This is given by what is called Stephen's law. Here T is temperature of the body or surface in degree Kelvin and EB is energy emitted per unit time per unit area. So unit of E will be joule per second meter square. Joule per second is watt. And the constant of proportionality EB is sigma B into T to the power 4. The value of sigma B is 5.67 into 10 to the power minus 8. Again, remember one thing. This law, EP is proportional to T to the power 4. This is an empirical law. You cannot derive this law. Like the Fourier law of thermal conductivity, you cannot derive. Like the first law, second law of thermodynamics, you cannot derive. They are all assumed to be applicable at all points of time. So this is an empirical law. From this we get total energy emitted by a body or surface whose temperature is T. The value of constant sigma B is 5.67 into 10 to the power minus. So suppose we have some body whose temperature is say 500 degree Kelvin. Temperature of this body is 500 degree Kelvin and we want to find out what is the total radiation, thermal radiation coming out of this. So we can apply this formula sigma B into 500 to the power 4. So we get the value of EB. One important feature of this Stephen's law is this is EB. Here subscript B stands for black body. Now what is a black body? Black body is a body which absorbs all incident radiation. A body which absorbs all incident radiation is called a black body. Such a body is hypothetical. Maximum absorptivity is that of snow, 0.985. This alpha is called absorptivity. What is absorptivity? 0.985. It means if we have some snow and some radiation is incident on that snow, say 100 kilojoule is incident on that snow, out of that 100 kilojoule, 98.5 kilojoule will be absorbed by the snow. This is the naturally occurring material which has got highest absorptivity. So we can consider snow to be a black body. So what happens if we go to hilly regions like Himalaya or where there is all the hills are covered? 0.985 absorbs all the incident radiation. Suppose this is a surface made up of snow and the incident radiation is Q, then it will absorb 0.985 or 98.5% of Q. Suppose this is 100 kilojoule, then 98.5 kilojoule will be absorbed by the snow. So black body is a body which absorbs all the incident radiation. So when there is black body, there must be some body which is called a white body. Yes, there is a body which is called white body. What is a body? White body. The board is not a white body. It literally meaning is not that like. So white body is a body which reflects all the incident radiation. Suppose we have a surface like this, the incident radiation is Q, and this body or surface is white, then it will what? It will do what? It will reflect all the radiation. It will reflect all the radiation. Like we have window pane glasses nowadays. We cannot see through that glass because it is highly reflective. The sun rays fall on the glass and they reflect all the sun rays, all radiations. So a white body is a body which reflects all the incident radiation. Now in this white body there can be two sub-bodies. One is called specular body and other is called diffuse body. In case of specular body, what happens is the body reflects the incident radiation in a regular fashion, only in one direction only. This is a specular body. Q is the amount of incident radiation and the reflection is only in one direction. That is specular white body. In case of diffuse white body, what happens is the incident radiation Q is spread in all directions. Some radiation in theta direction, some in theta 1 direction and some in theta 2 direction. So this incident radiation is spread everywhere at all angles. This is called diffuse body. Now from black body to white body we also have what is called not green, it's grey body. Third type of body is grey body. Grey, G-R-E-Y, no, it's G-R-A-Y, grey body. Now this grey body reflects a certain proportion of incident radiation. It absorbs certain proportion of incident radiation and it transmits certain proportion of incident radiation. We have seen earlier that radiation follows dual nature. It is a wave theory and the particle theory. So when we talk of wave theory, we can have the incident radiation Q0 to be split into three parts. One is QR, other is QA and the third one is Q tau. So suppose this Q0 is falling on this body. From this Q0 some radiation might be reflected, some might be absorbed and some might be transmitted. We have seen what is the black body. Black body will do what? Black body will absorb all the radiation. So this QA will be equal to Q0 in case of black body. We have seen white body. White body reflects all the radiation. So if this body is white, then QR will be equal to Q0. And when we say QR is equal to Q0, what will be the value of QA and Q tau? 0. If we have a white body and some incident radiation is there, it will reflect all the radiation. So absorbed and transmitted radiation will be 0. So if we equate this Q0 with QA plus Q tau plus QR, divide both sides by Q0, so we get QA by Q0 plus Q tau by Q0 plus QR by Q0. This ratio QA by Q0 is called alpha, this is called tau and this is called rho. This alpha is what? Absorptivity. Alpha, tau and rho will have some values. For black body, For black body, alpha equal to 1, tau and rho will be equal to 0, and for white body, rho is equal to 1 and alpha and tau equal to 0. Thank you.